All right, hello again. Our topic right here, we're still in chapter 0. Let me see, this goes up to 9, lesson 9. So we're getting there. We're getting close to finish up this chapter. It's called Linear Inequalities. The last lesson was linear equalities. This one is inequalities, which means they are not, the IN means they are not equal to each other. So we have a couple symbols we're going to talk about that represent things that are not equal. Of course, you know the equal sign. But let's say I had A and B, they're two numbers. And I'll tell you what, let's do this. Let's just say 5 and 2. All right, if I was going to compare these two numbers, they're not equal to each other, so they're unequal, or it's an inequality. 5 is not equal to 2. But if I wanted to be a little more specific than that, what could I say? I could say that 5 is greater than 2, or bigger. But we don't say bigger in math, we say it's greater than. So 5 is greater than 2. Do you remember these symbols? It's like this, okay? It's kind of like an equal sign, but watch. It's like an equal sign, but let's see if I can do this. But I kind of just tilted it. Do you see what I did right there? I made, it's a little small. Let's see. Yeah, there we go. See what I just did? I made the distance between the equal signs. I made them, let's see if I can, yeah. Here's the equal sign. I made this space bigger than what this space is. So that's an equal, or that's a greater than, greater than. I know some people, especially in elementary school, the teachers love to get real cutesy and stuff. I'm not all about the cutesy, even though I guess that's good for those teachers to do that. But they talk about, I don't know, like the alligator eating the bigger number. See how this is the mouth of the alligator? It's eating the bigger number. If that works for you, that's perfectly fine. Whatever works for you is good. But I just look at this. There's a bigger space in between these two lines here than here. So 5 is greater than 2. See, this is a smaller space. That's pointing to the small number. This is the bigger space. It's pointing to the bigger number. To me, I think that works just as well. But anyway, that would be greater than. Let me just write that down. So if you're reading from left to right, that's very important that I say that. That would be greater than. You could actually write or read it from right to left. Look, what would I say here? If I read from right to left, I would say 2 is what? Is less than 5. You see that? Because this is the smaller end, the pointy end. 2 is less than 5, or 5 is greater than 2. Either way, it means the same thing. Okay, or I could say 3 and 7. So what would I say here? 3 is what to 7? 3 is less than 7. It's smaller, but we say less than, and our symbol for less than looks like that. See how that's the pointy end, the smaller end? 3 is less, and this is the bigger end, the more open end. It's more space, okay, it's bigger than 7. 3 is less than 7. Or if you read it from right to left, 7 is what? Greater than 3. There are times where I think it's important that you are able to read it both ways. 5 is greater than 2. 2 is less than 5. 3 is less than 7. 7 is greater than 3. But for the most part, we're going to read it left to right, and so we'll call that symbol the less than symbol. All right. You could also have a symbol and do this. You could say that's our greater than symbol. You could put a little line underneath of it, and we could say that one number is greater than or equal to. That little line underneath means it could also be equal to. So one number, we'll just use A and B this time. So I could say A is greater than or equal to B. All right? So what if I said B was like 2? What would some possible answers? There's not just one answer. There could be a whole bunch of them. What's a possible answer for A? Remember, A has to be greater than 2 than B. So just give me a number bigger than 2. Okay, you say 3, 4, 5, 100, whatever. Okay, so let's just say 10. Yep, 10 is greater than 2. Is that true? Absolutely, if we're going by A is greater than B, and if A is 10 and B is 2. What if I said that A was 1? Would that work? No, because A has to be greater than B or equal to. All right, 1 is not greater and is not equal to 2, so that can't be true. What if I said 2? Could that be true? Remember, this says A and 2 is A, and 2 is B. A is greater than B. Is 2 greater than B? No. But this doesn't just say greater than, it says greater than or equal to. Is this equal to this? Absolutely. So that would be true as well. All right, hope that makes a little bit of sense. Same thing works with the less than or equal to. Let's do a couple problems. The nice thing about this, as far as the algebra is concerned, is that working these problems really is just no different than working a regular equality, with one exception. Okay, you knew there had to be something else. There is an exception though, all right, and we'll get to that in a little bit. But for the most part, and I'm not even going to talk about it until I get to the next, until I get to that particular example. For the most part, every time except for one time, you're going to use the basic rules for solving for x with linear equalities as you would with linear inequalities, except for for that one exception. All right, and we'll get to that in just a second. Let's go ahead and just do some quick examples. I'm not going to explain every little step here like I did on the last lesson, because hopefully you've learned that lesson and this makes a little more sense to you. Let's take a look at this. It says to solve right there, and this is what we're going to do. You work it just like it's a just pretend this was an equal sign. All right, this is not our exception. I'll tell you what the exception is. The exception is you're going to work this just like it's a regular algebra problem, with the exception if you're multiplying or dividing by, did I spell that right? Dividing by a negative. All right, that's the only time you're going to change something, and we'll wait till we get to that situation and I'll tell you what we're going to change. But are we multiplying or dividing by a negative here? Nope. What are we going to do? We're adding a 17, if you remember from the last lesson. All right, remember, do the opposite. That cancels out. X, now we don't change anything, it just stays exactly the same. Okay, this just drops down. If this was greater than to begin with, it's going to be greater than right here. So x is greater than, and then you just add these up, and that's 29, and that's your answer. So x could be any number that's bigger than 29. Now you're not going to sit there and write all the numbers that are bigger than 29. You're just going to write it like this: x is greater than 29. So let's do another one. I'll skip part B. Let's do this one. Let's go to example 2. This is t over 6 greater than or equal to 11. So again, what are we trying to do? We're trying to get t by itself, and we have to get rid of this 6. This 6 is being divided, so we do the opposite of division, which is multiplication. So we multiply both sides by 6. Multiply this by 6, and I come over here and multiply this by 6. Now, what was our exception again? Have we multiplied or divided by a negative number? No. We've multiplied, but by a positive number. So our exception doesn't take place here. So let's just do it like a regular algebra problem. So the 6 cancels out. I'm left with t. This stays the same. That doesn't change. And then 11 times 6 is 66. And that's our answer. So t could be any number that's bigger or equal to 66. So it could be 66 is our answer, or it could be 67, or it could be 66.1, or it could be 66.001, or it could be a billion. All right, any of those answers would work, but this is how we write our final answer. Let's skip part B to that because it's very similar to this. Now we're going to get into the exception part. All right, remember, what was our exception? Our exception was if we multiply or divide by a negative number. All right, I'll just put that. So let's see what we have right here. Here's the problem. Negative 5c is greater than 30, and we have to solve for this. All right. We want c by itself. So how do I get rid of the number that's with the c? It's this negative 5. How do I get rid of that negative 5? Well, it's being multiplied, so I always do the opposite. What's the opposite of multiplying by a negative 5? Well, it's dividing by a negative 5. What did we just do? We divided by what? A negative number. That's our exception. So we have to change something. If I divide the other side by a negative 5, if I divide both sides by a negative, I have to change something. So what do you think a wild guess would be what we have to change? Well, there's really only one thing to change, and that would be this right here. So instead of greater than, we're going to make this a less than. All right, so remember that negative and negative was a positive. That canceled out, so I'm just left with C. Now I change this from a greater than to a less than. 30 divided by negative 5 is negative 6. You say, well, why does that work? Well, because it works. I'll show you why. Pick a number. I'll tell you what, let's write that problem down again. What was the original problem? It was this. Let's pick a number that actually works, okay? C is less than negative 6. Okay, give me a number less than negative 6. Negative 7, how about that? That's smaller. Some of you guys might have said negative 5, but remember, here's a number line right here. Okay, and if negative 6 is right here, what's smaller? Smaller is to the left, isn't it? So that would be a negative 7. Negative 5 would be a bigger number. Okay, negative 7 is a smaller number. So let's stick a negative 7 in for this. Well, negative 5 times negative 7 is positive 35. Is positive 35 bigger than 30? Yep, absolutely is. So does this work? Can I pick a number that's smaller or less than negative 6 for this to work? Absolutely. I could go into a lot more detail, but that's more of an Algebra 1 topic, okay? So we'll just end right, well, we won't end right there, but let's move on. Let's do another one very close to this. This is letter B. This is part B of example 3. This is negative, and then D over 13, and then that's less than or equal to, and that's negative 4. All right? We're trying to get D by itself. So I have to get rid of the negative, and I have to get rid of the 13. Well, it's easy to get rid of the negative. I just multiply both sides by a negative. Put a little dot right here for multiplication. Remember I said 95% of the time I'll use parentheses. This is the 1-5% that I'll use a dot for the multiplication. So I have to get rid of this negative, so I multiply it by a negative, because negative times negative will be positive. Now, what's that 13 doing to the D? It's being divided, isn't it? It's dividing. So what's the opposite of division? It's multiplication. So if I multiply this by negative 13, look what happens. The negatives go to positive, and then the 13s cancel out. But what do I have to do over to this side? I also have to multiply this side by a negative 13. Look what I just did. What was the exception? If you multiply or divide by a negative number, you have to change the direction of your inequality. So originally it was less than or equal to, but since I multiplied by a negative number, then I have to change the direction of this inequality. I've got to change the way that it's pointing. So that all canceled out. I'm left with D. So instead of less than, I need to make it greater than or equal to. And then I just multiply 4 and 13. They're both negative, so it's a positive, and that's 52, I believe. And then that would be your answer. So any number that's larger than 52 will work for D. All right, let's do another one. This is good practice for our algebra skills here. This is example 4. Plus 13 and less than negative 7. All right. So we're trying to get A by itself right here. In order to get rid of A, I got to get rid of a couple things. I have to get rid of the negative 6 and the positive 13. If you remember from the last lesson, we get rid of what's being added or subtracted first. This is being added, so I get rid of it by subtracting, doing the opposite. So I come over here and do the same thing to the other side. Now, does subtracting something change the inequality? Nope. Only multiplying or dividing by a negative changes this. So let's bring everything down. This is, I'll tell you what, let's go back to that color. So we bring down the negative 6a. That cancels out. We don't change the inequality. Subtracting a 13 does not change the inequality. Bring this down, and that's negative 20. Now we have to get a by itself. So how do we get a by itself? We divide by a -6. We just divided by a negative. What does that tell you? If I divide by a negative, I have to change the direction of the inequality. That's our exception. So I divided by a negative. Bells and whistles and alarms should be going off. And you say, okay, divided by a negative, I have to change that inequality. So that went positive. That canceled out. I'm left with, let's make this red again. This A. Now I got to change that from less than to greater than. And now this negative over negative is positive, but I don't keep this 20 over 6. This does reduce. What divides evenly into both of these? Well, 2 divides evenly into both of these. 2 goes into 20 10 times, and 2 goes into 6 3 times. So it's 10 over 3. You don't need to change it to a mixed number. Just keep it 10 over 3. Just keep it exactly like that. And let's do one more just for fun. And let's see, what color do I want to pick? I'll go this orange again. All right, here's the last one. 4z. That's how I write my z's if I haven't written one yet. Put that little thing in there. I don't know why. I did that years ago, and I always do it. And then 8z minus 1. Okay, we want to get the z's on the same side. Now, with inequalities, it's really important that you read from left to right on an inequality. So on inequalities, I'm always going to put the variable on the left-hand side. Do you have to? No, you don't have to. But I think it's best to do it that way. All right, so that's what we're going to do. So I want to take this 8z. Remember how I said you always take the smaller one and move it to the side with the bigger one? If this was an equal sign, that's what I would do. But since it's an inequality, I'm going to move everything, excuse me, I'm going to move everything to the left-hand side. So I want to get rid of this 8z. It's a positive 8z, so I get rid of it by subtracting an 8z. And then I subtract an 8z from over here as well. Okay? That cancels out. I'll drop that down. Now, I got the z's on the left-hand side, so let's take the regular number, the constant, and move it over to the right-hand side. And I do that by subtracting a 7. Remember, you just do the opposite. Now, that will cancel out. So look, I've canceled out all my stuff. Let's drop everything down. 4z, let's change back to that color. 4z minus 8z is negative 4z. Now, I haven't multiplied or divided by a negative yet. All I've done was subtraction. So that stays the same for now anyway. And then that canceled out. Negative 1 minus 7 is negative 8. Again, make sure you know how to do that in your head. Now, I got one more step to do. I have to get rid of this negative 4. How do I get rid of the negative 4 if it's being multiplied? I divide. I do the opposite. So I do that to both sides. Okay, that cancels out, and that's a z. But what did I just do? Bells and whistles, right? And the alarms go off. I divided by a negative. So if I divide by a negative, then I have to change the direction of my inequality. So instead of saying greater than or equal to, I'm going to say less than or equal to. And then negative 8 divided by negative 4 is positive 2. And that would be my answer, just like this. Again, notice what I did. Talked about this on several occasions. I wrote the problem out. Okay, I wrote the problem out, showed all my steps, circled the answer, and then I can get credit for getting that problem finished. Okay, let's take a look at the problems I'm going to have you do. We are now on page P14. Remember, it's P14, not regular page 14. It's P14. It's chapter 0. And I'll tell you what, they give you 24 of them. I don't think you need to do that many. Let's do the odds again. Let's go 1 to 23. Let's go 1 to 23, and we'll just do the odds. I think that'll be plenty for you to get the practice on this stuff. All right, again, you're going to be working on this in class the next day, and I'll be there to help you, and you can get help from others around you as well. All right, hope this makes a little sense, and give you a chance to work on that tomorrow. All right, have a good rest of the night.